Now, will you be concerned about the team's capability in terms of checking the parts? You want them to accept good parts. You want them to reject bad parts. Is it so? Now there are 100 people. How do you know? You do an attribute agreement analysis.
Okay.
You randomly call 5 of them. Randomly call 5 of them, and if the miss rate is bad, and the team accuracy is bad, and the kappa statistics is bad, then you can understand a significant improvement is required. People really do not know how to check. If you don't take action, you know what will happen? Then all your lots will start coming back, and you will start getting a lot of customer complaints. So application is everywhere, wherever there is a checking, right? And wherever there is a checking by multiple appraisers. If there is only 1%, you just have to do the check the equipment, and no question of the reproducibility. Only repeatability you will be checking. But if there are multiple operators, checkers involved, you have to do all this. Got it?
Okay. Yeah.
Sir, at the end of the black belt, you will only know application. Here I can use. You will have to ask me this question, sir, where can I apply? But at the end of the master black belt course, you will be saying that, hey, here I can use it. Here I will use it. Here I am going to use it. Right? That's the difference between black belt and master black belt. Please do join master black belt later on. Thank you. Next time.
Okay.
Master black belt is learning through project. It's like management by objective. Learning by project. You have to have a project in hand, and then you are ready to join the master black belt. If not, we will assign you a project, and then we will make you join the master black belt, right? Anyone should happen, but definitely the learning is with the help of a project. Whatever tool you are discussing, you should be able to apply it in your project if it is required.
Okay.
So all of you, are you feeling good now with respect to the measurement system analysis? Come on,
Yes.
can you all come on video? I just wanted to have a check. All of you, please come on video. Yeah. Tell me, if you have to do...
I have again uploaded this file because that small one correction I made, no? So this you can download it if you want, right? Thank you. That can be deleted.
So suppose if you want to, if you want to conduct a measurement system analysis, right? You need to conduct a measurement system analysis, and now there are multiple operators involved in the data collection. Situation is multiple operators involved in the situation. Now tell me which MSA you will conduct. Will you go for the gauge study, or will you go for the attribute agreement analysis? Do you understand my question? If you want to ask for some additional information, feel free to ask.
Sir, we will go through AAA.
AAA.
Because we have a multiple choice.
Okay. You are doing gauge R&R for gauge R&R also for multiple operators.
Yes, sir.
Then which one I should go? Gauge R&R or the AAA?
AAA, sir.
Why? What is the difference between gauge R&R and AAA?
No, sorry.
Others? Yeah, others. Please try. What is the difference? Gauge R&R, was that taught to you, all of you? What does R&R mean?
No, gauge is something I think I'm hearing for the first time.
Gauge R&R. Okay, sir. Gauge R&R, you said no, that was explained by Shivashish.
Gauge R&R, was it not explained to you the previous day, Sunday?
Second day. Day 2.
Oh, sorry. I'm not able to recollect actually. I need to revise it.
Anyway,
I'm
gauge
able to
means
recollect
what?
it.
Gauge means instrument. Yes or no?
Okay.
No, at least all of you know.
Bias was not taught you, yes or no?
Yeah. Okay.
Right?
Okay.
Hmm.
Yes.
bias, linearity, stability, right?
Yes.
And then gauge R&R, it should be more than 90%, right? 10% error is a part error, part to part error, repeatability error, reproducibility error.
See, I want to help all of you unless and until you let me know. See, I have kept two options now. I have reserved the time to teach you, either the gauge R&R or there is one more lighter tool similar to your Kano model, right? So, which one do you think you want to discuss now? Do you want me to discuss the gauge R&R or you want me to discuss the define phase tool?
See, last time, even my session was postponed because I'm doing it what I should have done it last week. So in my class also taken to explain this gauge R&R. Anyway, it doesn't matter. I think you guys will have to repeat it, sir. Better.
But anyway, all of you, please, first of all, you open the discussion. Otherwise, simply repeating the discussion is like, replaying a video. You can always go through the video. So please, all of you come on video. I already said, right? Unless and otherwise you are not ready, right? So please come on video.
Yeah, you are not coming on video. All of you, please come on video.
See, you can stay in your comfort zone, but unless and until you come out of it, you can't learn certain things, right? Now I demand it because I really wanted to understand, maybe at least looking at your face, whether you really attended the session or not. Please tell me, bias taught to you or not? Bias. Bias. What is bias?
Centricity of any equipment.
Bias. Difference between the reading, measured reading and the true value. If I measure 100 mm as 105, now the bias is 5 mm.
Yep.
100 mm is the true value, but you are measuring and telling me that the reading is 105. That means your reading is not accurate. See, what RK was talking to you was about consistency. He was talking about consistency, whether all of you are agreeing or not. But now bias is talking about accuracy. Are you correct or not? Are you correct or not? Like, the 100 mm should be measured as 100 or close to 100, but not 105. If the bias is too much, the readings becomes useless. Because the overall error permitted is how much?
Sir.
Only 10%.
Sir, all of you know what is zero error? Near weighing machine or any machine, no? There is a zero error. Understood? You know that?
Yeah.
That is nothing but bias. That is nothing but bias. Right?
Yeah.
My watch shows 10 minutes faster. What is bias? 10 minutes. If my watch
10.
shows 2:10, and if you are asking me time, what I will say? 2 o'clock. My watch showing 2:10, but I am going to tell you 2 o'clock. How I am telling? I know the bias. So I subtract and then tell you the correct time. Yes or no?
Okay.
So bias,
Yes.
bias can be sorted out. It can be easily solved.
So you sort out the bias.
Using a jargon called calibration chart. Those of you who are working in industries will know what is calibration chart.
Okay. So bias may be plus or minus, sir?
Yes.
Yes.
Yeah. Okay.
Bias can be plus or minus, and then if you find a way to correct the bias, the procedure is called calibration. It can be a calibration chart. You are not correcting your equipment, rather you have a calibration chart. Another thing is you can correct your equipment, which is the process is called calibration. 3 months once, 6 months once, yearly once you can calibrate and you can maintain your equipment. So all these things will bring down the bias. Right? If the bias is well defined, constant, then you can create a calibration chart. Otherwise, you have to calibrate your entire equipment. Probably replace certain components and do the maintenance, and then it will start giving bias-free reading or error-free reading. And bias, there are two requirements. It should be stable and it should be linear. Stable in the sense, it should remain same over a longer period of time. If you do the calibration, now bias is 0. It should remain 0 at least for next 6 months.
Yes.
Then the equipment is stable.
Okay. So it's depend on what is our calibration. Okay.
True.
According to
I use the equipment to measure a very small value and a very large value. Let's say 1 ampere current and then 100 ampere current. Now my bias while measuring the smaller value as well as the bias while measuring the larger value, it should be same. Always when you are using measuring equipment, you have to choose the equipment in a way that the bias is constant. If the bias is not constant and you are still using it, then your calibration chart becomes complicated and then you will make your data less and less meaningful, right? So you have to make aim for bias-free reading. If bias-free reading is not possible, keep it low bias, and importantly, bias should be stable. Bias should be linear within your working range. All these things will make your data, worthy and credible for analysis. Otherwise, what happens? Your data will become unworthy, and then it is completely useless for any analysis. But you still do analysis, you take decision, and all your decisions, will go wrong. So this is one thing you all need to understand. And on the other side, consistency. In fact, consistency is the key always. Consistency is the key always. Then comes accuracy. But we spoke about accuracy. But prior to accuracy, what is required is consistency. Imagine you are not a good singer. You are not a good singer. I believe so, right? Are there any singer here? If you are here, then you can actually you can plan a song in the tea break, right? Suppose imagine you are not a good singer, but you want to sing. So what is important first? Every day, early morning, you should sing for. You should sing for 30 minutes. 30 at least minutes. In the bathroom, wherever you like. You must start singing. So if you are doing it consistently for a longer period, after let's say 6 months or 1 year, you will see you are singing nicely. Isn't it? So same manner, first thing you need to check is the consistency. If the data is continuous, you must do a gauge R&R study. If the data is attribute, you must do attribute agreement analysis and kappa analysis. All of you, do you understand why we are learning all these things?
Yes, sir.
Right? So once the consistency is achieved, then you can plan for improving your accuracy. Like now you can buy a very good mic for singing the song. You can set your throat. You can do everything. All that is calibration. You are calibrating. Now you will really get very nice voice, right, out of your throat. Same way, if you make sure the gauge R&R is less than 10%, you make sure the attribute, the kappa analysis, kappa statistics is 0.9 and above, and if the miss rate is acceptable and team accuracy is acceptable, then all good. All of you understand now? This is the logic. And now we are equipping you with the templates. These templates, even if you want to do mistake, it will not do any mistake. You should know how to conduct the test, collect the data, feed it in the appropriate places. Everything will be calculated. Now, since I feel you have a little challenges with the gauge R&R, I would like to conduct a gauge R&R study right now and then quickly see whether I can do the analysis for you. Now, can one of you tell me what is repeatability and reproducibility? Any idea? Repeatability and reproducibility.
Repeatability, I mean, where there is a two member and one person is saying something, second person is, if you ask a question, the answer will be same. So 2 person giving identical answer will be repeatability.
Very good. 2 persons giving identical answers is repeatability. Is it 2 persons is repeatability or same person is repeatability?
It can be same person.
Same person is repeatability. Then what is 2 persons? If two appraisers give the same reading, what is it?
That would be reproducibility.
Very good. Reproducibility, right? That's what we are going to check now. Just give me a second. I'll. I get the gauge under slide. Okay, I got it. So I suggest all of you, so I'm not going to record this because recording this, well, we are going to do an activity. So let me stop the recording. All of you
Yes.
confirm whether my screen is.
Yes,
Yeah.
sir.
So we are measuring something called a gauge R&R. What is this gauge R&R? Gauge R&R is precision error divided by tolerance, right? Precision
Sir,
error.
excuse me, sir. This gauge spelling is something like GAUGE, no?
No, it is this only.
So it is different
You
for
can see
our
here.
gauge.
You can see here. This is gauge only, right?
Okay.
So both spellings are used, but here it is gauge only. Now,
Okay.
now the precision error. Precision error is nothing but sum of repeatability error and reproducibility error. Hope all of you know the meaning of repeatability error and reproducibility error, isn't it?
Yeah.
Right? So this repeatability error is nothing but six times standard deviation of, or standard deviation for, you need to calculate the standard deviation in a specific way so that you capture the error. Sigma is the error, all of you understand. So the difference in the reading is the error. The difference is captured statistically using standard deviation. So you calculate the standard deviation to capture the error and multiply by 6 so that you get total error. Similarly, 6 times standard deviation for reproducibility. I'm only explaining, all that Minita will do it for us. Now, what is tolerance? Tolerance is generally provided by customer, am I right?
Yes.
QSL minus LSL, upper specification limit minus lower specification limit. This ratio will give you gauge R&R. This gauge R&R must be less than 10%. If it is less than 10%, the measurement system is acceptable. If the gauge R&R is 10 to 30%, your measurement system is conditionally acceptable. If it is more than 30%, measurement system is unacceptable. Better don't collect data. Now, see here, like how I involved several people here. See here, I involved Santosh, Yadav, our Sadish Gade and Venkat in the data collection. But here, same manner, I have involved an operator called Ganesh. Then next operator is Sashi Shekhar. Next operator is Gaurav. The next operator is, so how many operators here? Only 3 operators. Can you see Ganesh, Sashi, and one more is Gaurav. And again, I have made them to collect again. This is to measure the repeatability. Again, Sashi, Gaurav, and Ganesh. All of you, do you understand?
Yes.
3 operators, 5 songs played. Song number 1, song number 2, song number 3, song number 4, song number 5. And every song is played twice. All of you understand?
Yes.
3 operators, 5 songs, each song 2 times. 3 into 5 into 2, how much?
3 into 5, 15 into 30.
30. And can you see 30 experiments?
Yes.
With the 30 experiments, you can judge whether the measurement system is going to help you in the project or not. If you have still not collected data, please understand. We have still not collected data. We are getting ready for data collection. All of you, do you understand where are we? We are getting ready for data collection. We are just ensuring ourselves that our measurement system is good to go. Then only we'll collect data, right? And now with all the data, what you need to do is you just have to go to stat, go to quality tools, go to gauge study, go to gauge study, and then go to gauge R&R study crossed. The study is called crossed because the same song is played for all of you.
Okay.
If all of you use the same product during the gauge R&R study, your study is called crossed. Do you understand?
Okay.
If I select 5 products randomly from your company and all of you measure the same 5 products, now the study is called crossed.
Cross.
Suppose I select 5 similar products for Santosh and similar 5 for Yadav and similar 5 for our Satish and similar 5 for Venkat. Products are identical. I mean, similar, but not exactly same. Do you understand?
Okay.
Similar product, readings are expected to be same, but actually they are not identical. Under such situation only, you should go for nested.
Okay.
Right now, same product is used by all the operators, so I'll go for crossed. All of you understand why I'm going for crossed?
Okay.
Now you click. Now it is asking part number. Where is the part number? Part number is typed in column number 2. Am I right? Song is considered as the product here.
Okay.
It is contained in column 2. I select column 2. Operator detail. Operator detail is available in column 3. Measured data available in column 4. Now
Okay.
ANOVA method, X bar R method. Let us go for X bar R method. Now you just give, go to options. You remember 6 is here. I also told you have to multiply by 6, isn't it?
Yes.
6 times standard deviation. Now upper spec, lower spec. The lowest duration is 20 seconds. Highest duration is 60 seconds.
Yes.
Now the upper spec, the difference between upper spec and lower spec is 40 seconds.
40 seconds.
40. Now with this information, I am giving OK. Again OK. Now the gauge R&R study is done. Now let us go to the report. Look at the gauge R&R. How much it is?
Gauge and R and R. 1.
No, I have highlighted gauge R&R. Total gauge R&R is 28.59.
Okay.
28.59 is conditionally acceptable.
Conditionally. It is greater 28. It is
10 to 30. It is in the center. 10 to 30% range.
okay.
So
10 to
conditionally
30.
acceptable.
Okay. Yes.
Less than 10% is required. When I say lower spec is 20 second, upper spec is 60 second, this measurement system is conditionally acceptable.
Conditionally acceptable.
Maybe you have to go for next level.
Okay.
Maybe millisecond level you have to go. In order to, otherwise you have to probably try to improve the consistency. Like tell all your people automatically repeatability will come, reproducibility will come, the error will go down.
Yes.
Because nothing to find fault with the measuring equipment, because it is having a good resolution 0.01, and all of you have the smart device which is working fine. So improvement is required in the operational definition, in the appraiser skill. That's all. And now 28% is the gauge R&R, out of which repeatability is the major problem. Reproducibility is not much. Reproducibility is not much. It is showing 0, but it means not much. So the problem is with the repeatability only. Now, who is causing problem? Can we figure out? Because repeatability means operators' ability to produce the same reading. Let us look at the graph, and then probably we will be able to find out. Now look here. There is an R chart. Can all of you see R chart?
Okay, sir.
Now
R
in
chart
this
by
R
operator.
chart, first operator Ganesh, second operator Sashi, third operator Gaurav.
Alright.
Now who is problematic?
Sati.
Sashi.
Sasi. Yes, sir.
Now Sashi is struggling to measure the parts consistently.
Okay.
He is not aligning with the procedure. He is not aligning with the instruction. Do you understand? Now when I train him on how to measure, probably the repeatability error will come down.
Okay.
As the repetitive error comes down, your gauge R&R will also come down. If the gauge R&R goes below 10%, your measurement system becomes acceptable. Clear?
Okay. Yes.
Similarly, every graph can speak. Now, by the time you have learned so many tools, you should be very good at reading each and every graph. Now, reproducibility is not a problem. And that is why, we just have to look at the R chart. But if reproducibility is also a problem, that will appear in the fifth graph. What is fifth graph? Box plot.
Box plot. Okay.
In the box plot, this is the center is, this is the average, first average.
Average.
This is second average, this is third average. If all the three average align in the horizontal line, perfectly reproducible. That is why, in this case, reproducibility is 0. So only slight angle is there.
Okay.
Suppose if the first person, Ganesh reading is center is above, what does it mean? The system will become poorly, poor reproducibility.
Okay.
The measurement system will lose the reproducibility if one of the operator keeps his average above or below. Now that operator must be advised, must be given the training so that all the average comes on a horizontal line. Perfect horizontal line. I connect the averages here. If they come in the horizontal line, then reproducibility is also perfect. So this is how you just have to do it. So hope all of you understand. Any questions to me on the gauge R&R?
Yes, sir. So what will be the what will find out from the graph operator interaction?
Very good. See, the operator interaction graph is nothing but overlapping of the X bar chart. Can you see X bar chart here? Number 1 and this is number 2, number 3. I am overlapping. The 1 is converted into a green color graph. The 2 is converted into the red color graph.
Okay.
See here, 2 and 1 are not overlapping. Particularly for the first 2 parts. Can you see that?
Yes.
Particularly for the first 2 parts, there is a problem between 1 and 2. Number 3 is given in green color. Number 1 is blue, number 2 is red, number 3 is green.
Number 3 is green.
If the blue, red and green overlap, that's an ideal scenario. That is the best system.
Okay.
If they are not overlapping, they are separating, you can tolerate to a certain extent, but not to the extent of intersection and dancing like number 2.
Okay.
Number 2 is dancing. Can you see that? It is crossing. That means, you are telling him to go in a direction, but the operator 2 is going in the opposite direction. Can you see that happening? You are expecting him to measure in a particular way, but he is doing exactly opposite. That is now getting visualized. This is called interaction. Particularly, he is behaving erratically while measuring the part number 2. Can you see that in the picture?
Yeah.
That is why it is called part operator interaction. A specific part he is struggling to measure when you are conducting the gauge study. So probably operator 2, I will train him on part number 2. How to measure part number 2. Part number 2 may be your Bahubali song. He got distracted very much. Like our Yadav also liked that song, isn't it? So same manner, there could be some issues. Sometimes while measuring a particular part, there could be issues. And similarly, this graph, you see here, this is called measurement by part. Every single part is measured by 3 operators. And each part is measured 2 times. 3 into 2, 6 readings.
6 readings.
Every song is measured 6 times. I mean by 6 readings. Ideally, all the 6 readings should be same, like the 3, 4 and 5. Can you see 3, 4 and 5? Only one point is visible.
Okay, 3, 4, 5.
But look at 2. But look at 2. The points becoming
different
scattered.
from the straight line. Yeah.
So song number 2 is creating problem for all the appraiser. I do not know what is song number 2.
Okay.
Song number 1 also creating problem. So your people should be trained to measure all the 5 parts uniformly. So each and every graph will speak and you will be able to bring down the gauge R&R study, particularly when your data is continuous. We consider data as continuous when it is measurable. Time is measurable. You measured it right now. So conduct the gauge R&R study. The goal should be less than 10%. You must look at the yellow color bar when the tolerance is given. I have given the tolerance. So look at the yellow color bar. for the gauge R&R, because we are now finding out the ratio with respect to the tolerance. If tolerance is not available, then the ratio will be calculated using the steady variation. Just using the variation in the data, total variation in the data is considered the reference. Error should be 10% of the total variation in the data. But if you give the tolerance, error should be 10% of the given tolerance. All right. So I just would like to stop here.
For lesson solution. Okay. So you pay attention.
So once again, very good morning, all of you.
Good morning.
Good morning, sir.
Yeah. So this particular session, we are going to learn correlation and regression analysis. Already, you must have some basics. Correlation is trying to understand the linear relationship between two variables, preferably your x variable and y variable. The x variable is the input factor, y variable is the output, right? Y variable is the dependent variable, x variable is the independent variable. If there is one x variable and one y variable, we call it correlation analysis. If there is more than one x variable and we want to understand its relationship with the y variable, then we call it regression analysis, and we will understand both in this particular session. So listen very carefully, because the tool is easy, but at the same time the application is very wider. So you have to master this, so that as a black belt you will be able to handle any situation in your project. Correlation and regression analysis, terminologies that are used in regression, and what is regression model and what is prediction model. And we will also talk about confidence interval and prediction interval, and few case studies also we will be seeing as we discuss about all these tools. So as I already mentioned, correlation is studying the relationship between one x variable and one y variable. The one x variable is called as predictor variable. All of you can see, the x-axis. The x-axis is known as predictor. You can see this here is called a predictor. This y-axis is called response variable. When I change my x continuously, what will happen to the y?
It's also change.
Yeah, this will also change. This is what we are trying to understand. Let us say I keep on adding some sugar to my coffee. What will happen to the sweetness of the coffee? That will also keep on increasing. Similar trend we are observing here. I keep on increasing the x. The y is also keep on increasing. Right? Keep on increasing. And so for each possible x value, and the y value is recorded and it is plotted. Now I could see the y values are forming a pattern. The pattern is found to be a straight line. I think all of you can easily make out by looking at the number one. Looking at the graph, number one. The graph one is called scatter diagram. The graph one is called scatter diagram. I could clearly see a pattern. And what is the nature of the pattern? Linear pattern. Now I will conclude the relationship between the x and y variable is positive. Why do I call it positive? Because increasing the x increases the y. So it is positive. Moreover, the pattern is very strong. I could immediately conclude it is straight line. So that is why I say strong. All of you do know the meaning of strong, meaning of positive. And moreover, when the points are forming a perfect straight line, you can even replace the word strong by perfect. You can say strong positive, you can say perfect positive correlation. So correlation means studying the strength of relationship between x and y. Coming to the second scatter diagram, here I could see when I increase the x, what happens to my y?
It also decreases.
It is decreasing, not increasing. You can see that. The line is downward. Can you see? Increasing the x decreases my y.
Why? Yeah.
So now the relationship is negative. I can say strong. I can also say perfect, because it is a perfect line. Because it is a perfect line. And I will use the word correlation because I am very sure that the pattern is linear. So correlation measures the strength of linearity. Correlation measures the strength of linearity. Look at the third diagram. The third diagram, the points are completely scattered. I am not able to judge, are there any relationship between x and y? I am not able to judge whether my x is influencing y or not. I keep on increasing the x and y is behaving, in its own manner. Now I will conclude there is no correlation. All of you, do you understand the meaning of 3 scatter diagrams?
Okay.
Yes.
Sir. Yes, sir.
Now, moving on to the next slide. Now, if you have some problem in judging, you can rely on this formula. This formula is called,
Yes.
correlation coefficient, Pearson correlation coefficient, R value. The R can be calculated using X bar. What is X bar? Average of the X values.
X value.
Y bar, average of the Y values. Sx, standard deviation of the X values. Sy, standard deviation of the Y values. N, number of samples. Xi, individual X values. Yi, individual Y values. If you substitute, you create a table and then you can calculate the R value. All of you could have studied this in your graduation. Now I am showing a scatter diagram. Now look at the scatter diagram and tell me what kind of relationship you could make out. Is it positive? Is it negative? Is it strong? Is it perfect? Please tell me.
Positive correlation.
Positive correlation.
Pause.
I expect you to make out all statement. Positive, I agree. Strong or weak or perfect?
Seem to be strong.
Strong positive, sir.
Strong positive. And
Strong
those of
positive.
you who have doubt whether it is strong, seem to be strong, you don't have to worry, you can use the formula.
Yeah.
You can use the formula, right? Because you are not sure about your eyes, you are not able to believe your eyes. So you can use formula. That's why the formula is created. Now the formula, when you substitute the values, it will generate a coefficient, which is called Pearson correlation coefficient. That will lie between -1 and +1. You can see -1 and +1. And so 0 to +1 is called positive correlation values. And 0 to -1 is called negative correlation values. So 0 to 0.4 is weak correlation. 0.4 to 0.7 is moderate correlation. 0.7 to 1 is strong correlation. And exactly 1 means perfect correlation. Similarly, on the negative side, all of you, do you now understand why we have this formula? Either you make your conclusion looking at the graph, or you use the formula and generate the value. Now I'm going to test your understanding. First scatter diagram. Now tell me, what is the kind of relationship you are seeing? Is it positive, negative, strong, weak, moderate, perfect? What is your opinion now?
Sir, it is a strong perfect. Positive, sorry, strong positive.
Yeah, strong positive, not perfect. And that is confirmed with the R value. See here, Pearson correlation coefficient.
Yes.
Now this one. Come on, tell me.
Perfect negative.
Strong negative.
Strong negative.
Strong positive, strong negative. Here.
No correlation.
It's very
Here.
big.
Deep correlation.
Look at the R value, 0.255. Weak positive, weak negative.
Negative.
And now,
No relation, sir.
No relation, sir.
no relation or no correlation.
Yeah.
No correlation.
No correlation as well as no relation, as far as the third column is concerned. But now when I bring one more, here no correlation, but there is relation.
Relation, yes.
Because correlation is measuring the linearity.
Yes.
Linearity means straight line.
Okay.
But non-linearity can exist. But for this diagram, nothing exists. So you can say no correlation, you can say no relation. But for the last one, you can say no correlation, but there is relation. What is the shape of the relation? Can somebody tell me?
Parabola.
Parabola.
Very good. Parabola means second relation, quadratic relation.
Quadratic relation, yes.
In all the first 4 cases, there is only x involved, but here x square is involved. Right? So here there is no correlation, no relation, but here no correlation, but there is parabolic relationship. So I think all of you are perfect alignment now. And now what is regression analysis? So far we have understood about R, which is the correlation coefficient. And now in the every scatter diagram, you can see a line, here there is a line, here there is a line, and here also there is a line. These lines are nothing but the regression lines. These lines are nothing but the regression line, nothing but the mathematical equation showing the relationship between X and Y. Right? And so regression means the mathematical equation describing the relationship between the predictor variables and the response variable. Using the regression, you can understand the direction of relationship. You can understand the size of relationship. You can also understand statistical significance. Statistical significance means p-value. Whether your conclusion is making sense in real time or not, p-value can tell. And you can use the mathematical equation as a prediction model. So what is prediction model? We are going to talk. And generally regression analysis, in order to frame the regression equation, we use a method called principle of least square, or called the least square method. This will ensure the error is minimal. This will ensure the error is minimal. Otherwise, what happens? You will frame an equation and then equation may not help you to predict well, right? So that's the method. We'll see all these things. Terminologies used in regression. Model order. Model order means linear model means first order. Quadratic model means second order. Cubic model means third order, right? So model order. Another thing is regression equation, the exact mathematical equation. And then regression coefficients. And then we have residual. We must understand on all these things that we will be discussing. So linear model, see here, when my equation is like this, y equal to ax plus b, only x is involved, all remaining are constants. If I know the constant, my equation is available. Let's say a equal to 0.2, b equal to 0.3. Now regression equation is available. And this is what we have studied in lower classes. Y equal to mx plus c. Hope all of you could recall.
Yes.
We always use y equal to mx plus c, where m is the slope of the line. Where m is the slope of the line.
Yes.
In linear equation, the slope will be constant. In linear equations, the slope will be constant. Only one line. Wherever you measure, the angle will be same. 30-degree line means it is 30 degree throughout. So the slope will be constant. If the slope is constant, the model is linear. If the slope is not constant, the curve will have twists and turns. It may go up, down, and it will start dancing. Those curves are called non-linear, right? So the linear model is order 1. Quadratic model means ax squared plus bx plus c. Here the main difference between linear and non-quadratic is x square is also involved.
Yes.
Yes, sir.
Slope will not be constant. Slope will not be constant. And cubic model means x cube will be available, right? And nature of the graph also, I think I'll show you, right? And now linear means you all know, you have seen already, it's a straight line. Quadratic means it is like a parabola.
Parabola.
Yes.
Cubic means the curve will go upward and then will start coming downward. Upward, downward, upward, downward. So
Yes.
it can move upward and downward, alternatively. That's why it is cubic, right? Your y can change from plus to minus, right? That is why it is cubic. And now let us take a case. There is an equation here. You all can see weight gain equal to minus 754.6 plus 0.4631 calories consumed. What is predictor here? Calorie consumption is predictor. You consume more calories, what will happen to your weight?
More weight.
More weight. That is what you are seeing here in the graph, in the regression line. See here, your what do you call the line is moving upward, right? And moreover, the equation is derived, complete equation is derived. I can even teach you how to derive this equation. Now, the weight gain is nothing but your y variable, right? Let me take the pen. This is your y variable. And this is your constant term C. Am I right? This is your constant term. The 0.4631 is your slope. The slope is always denoted as m. So now the equation is y equal to mx plus c. Now I want to know the slope, I want to know the constant, so that I can write this equation manually. Otherwise, you can generate using Minitab. Suppose if I want to write this equation manually, how to get the m? Can somebody give me an idea? How to know the slope of the line? Can I take protractor and measure this angle?
Yeah.
Possible. After measuring the angle, can I take tangent of the angle? You all
Yes,
know
sir.
tangent, right? Tan theta.
And theta. Okay.
Yeah, tan theta.
When I take tan theta, m will be obtained. You can try. All that required is just the line. You draw the slope. I mean, you draw the line. Use your protractor, measure the angle, and m equal to tan theta.
Yes.
Another method is you draw a horizontal and a vertical. Now the length of the vertical is delta y. The length of the horizontal, right, up to this, from here to here. This is del x.
Del x.
Now you find out del y by del x. Del y measured in millimeter. Similarly, del x also measured in millimeter. What is this ratio del y by del x?
M.
This is also m.
Weight upon consumed calorie.
See, this is a right angle triangle. Am I right? Right angle triangle.
Yes, sir.
Theta is here. Your del y is opposite side. Del x is adjacent side. What is opposite by adjacent? Tan theta.
Tan theta.
So you follow any method. Del y by del x also gives m, or directly tan theta also gives m. This is nothing but 0.4631. You can try yourself, or if you do not have time, you can rely on Minitab. All of you understand how the m is coming?
Yes, sir.
M has got significance. M has got significance. What is the signature of M? Positive or negative? Positive or negative? M is positive.
Positive.
Positive, yes.
So the relationship between X and Y is positive. So the relationship between X and Y is positive. And 0.4631, the number is giving you a clue. What is this number is telling you? When I increase the X value by 1 unit, Y value is expected to increase by 0.4631 unit. All of you, do you understand my meaning of my statement? When I
Yes, sir.
increase X by 1 unit, Y will increase by 0.4631 unit. Because what is your goal? You want to improve the Y. In order to improve the Y, you have an improve phase. Am I right? In the improve phase, all your team members will be sitting. You are going to brainstorm. How to increase the Y? Here, the equation is giving you the guidance. You don't have to rely on an expert, outside expert, isn't it? What is this equation is telling? Increase the X, your Y will increase. Suppose if Y is the strength of the material, or Y is the resistance of your circuit, you want to reduce the resistance. If you want to reduce the resistance, then you have to reduce your X. I do not know what is that X. You have the process knowledge. You know the Y and X and everything, isn't it? Reduce the X, Y will reduce. Increase the X, Y will increase. And how much it will increase? When I increase X by 1 unit, Y will increase by 0.4631 unit. Every secret about your solution is now available in this mathematical equation, provided the equation is a good equation. Because equation is derived from the data. Data is obtained from the experiment. That is why your data should be clean and credible. That is why your data should be clean and credible. Measurement error. We talked about gauge R&R, attribute agreement analysis, and all those things. All right. Now, what is this C? Called, y-intercept. Where is this line going to intersect the y-axis? Where is this line going to intersect the y-axis? When I extend the line, can you see the line intersecting y-axis somewhere here? Tell me. Can you see the line cutting the y-axis or crossing the y-axis at this point? Please confirm. Can you see here?
Yes,
Yeah.
sir. Yes.
The point is below 0 or above 0?
Below 0.
Point is 0.
Very good. Whatever is the value, you write it down here. This is minus 754 in this case.
Yes.
Below 0 means minus.
Minus.
All of you, do you understand how the y-intercept has come? How the m has come? All that required is a graph sheet and a set of data. Plot the graph for yourself. Take your protractor and take the scale. Find out the m. Find out the c. Now your regression equation is ready. right? Fully handmade regression equation is available. So regression can indicate the direction and size of relationship, and the sign of the coefficient indicate the direction, and its magnitude represents the change you can expect in the response variable. The 0.4631 is known as regression coefficient. All of you understand what is regression coefficient here? 0.4631 is known as regression coefficient. Very good. We move on. And now we are going to slightly visualize. Look here, this equation. Look at the equation. The equation is y equal to x. Now what are all you can say about this equation y equal to x?
We can say that the value value of x is equal to value of y. That means if we proceed with some value of x, then it is a direct relationship between.
Very good.
Y.
Correct. X and y are same. That means here, first of all, the relationship is positive.
Yes,
Why
positive.
it is positive? Because regression coefficient is 1.
1. Yeah.
What is this 1 is telling? When I increase x by 1 unit,
y
will also increase by 1 unit.
1 unit. Okay.
You see here, increase x by 1 unit, y increase by 1 unit.
1 unit.
Another 1 unit, another 1 unit, another 1 unit, another 1 unit.
Yeah.
But coming to this equation, when I increase x by 1 unit, what happens to y?
2 times, sir.
So the equation of the line is y equal to 2x.
2x.
Here y equal to 1x.
1x.
Here slope m equal to 1. Here m equal to 2. But both the line are passing through origin. When the line is passing through origin, what is the y-intercept value? C. C is 0.
Okay.
That is why there is no C here. Right? So we have discussed all possible situation. With the C, without C, m equal to 1, m equal to 2, and m equal to any value. And now coming to this equation again, weight gain equal to minus 754.6 plus 0.4631 calories consumed. What is this telling? Predictor variable, x variable. I increase the x variable by 1 unit. X is increased by 1 unit. Now, how much increase I can expect in the y variable?
1. According to graph 1.
See, this is about this equation. Yeah, you forget about the graph. Now, look at the equation and tell me. When I increase,
0.4631.
can you see?
Yeah.
0.4631 increase in the y variable.
Yes, sir.
Right? This is what you can expect. On an approximately, y can increase by 0.4631. So this is the meaning of the equation. Hope all of you have understood. Now let us talk about residual. Look at my scatter diagram. There are red color dots. The red color dots are nothing but the experimental values. Am I correct?
Yes, sir.
Red color dots are nothing but the experimental values. But I am interested in writing the equation of the relationship, which is the regression line. The regression line is indicated in blue color line here. I think all of you can confirm it, right? The regression equation is the blue color line.
Yes.
Our regression line is assumption of the relationship. It is not the actual. Actual means, it is going up and down. You can see. See, the points are actually going up and down. Can you see? It is going like this. But I am going to assume that the relationship is linear. So there is an error. Why there is an error?
What happened?
Okay, I think there is some net connectivity issue. Am I back in the meeting?
Yeah, you are audible.
Yes, sir.
Yeah.
What was I?
Y is equal to,
About residual, am I right?
Yeah.
yeah, residual.
Very good, very good. Okay. So now the residual is nothing but the distance by which we either pull down the observed value or pull up the observed value so that we can see them on our assumed regression line. And that means your regression line is an assumed relationship. Am I correct? The assumption should be close to the reality. If you want your assumption to be close to the reality, you draw the regression in a way that the line is close to most of the point. You draw the regression line in a way that the line is close to most of the point. I can draw the line wherever I want. Let me draw it for you. See here, I'm drawing the line. Now what will be the amount of residual? Residual will be now too high. When I draw it here along the blue color line, the residual is minimum. That is the reason why I have drawn it here. This idea is to ensure the residual is less. The error is less. This is called, in order to ensure our residual is less in our regression equation, we use this technique, and this technique is called principle of least squares. Why it is called the principle of least squares? The deviation is error. In the first case, the deviation is positive. Suppose when I pull up, the deviation is negative. Can you understand? Your point can be above the regression line. If the point is above the regression line, residual is positive. If the point is below the regression line, residual is negative. So in order to ensure residual is minimum, I am using the squared value of the residuals. The sum of the squared values of the residuals should be minimum, which is called principle of least square. Look here for this point. The observed value is 380 or the actual value is 380, but the fitted value is 350. So residual is positive. For the same thing, for the other point, the residual is negative. Since the residual is negative, when I simply sum them, it will cancel each other. So in order to minimize the cancelling effect, I square them and then add them. That's why, the sum of the squared values, I'm targeting the sum of the squared values to be minimum, which is called principle of least square. Now a linear model means it will appear like this. Quadratic model means it will appear like a parabola. Cubic model means it will appear like this. So you get an idea about what kind of regression will best work for you by referring to the basic tool called scatter diagram. What is the basic tool? Scatter diagram. Scatter diagram is one of the 7 basic quality control tool. Right? You should know how to use it. And now this equation can be, derived, and you can actually draw conclusions, right? Now, let us do a small case study. There is a set of X value as well as Y value. The X values are calorie consumption. You can see the calorie consumption is mentioned in the unit followed is calories, and weight gain is observed. Weight gain is measured in grams. The method is an individual is advised to consume 1500 calories for 1 week, and every single day the weight gain is observed. All 5 days, if there is no weight gain, you can mark it as 0. Similarly, for 2300 calories 1 week, every single day, approximately 200 gram weight gain is observed. If you have multiple readings, let's say 7 readings, take the average of the 7, that is written here. All of you understand how the Y value is generated? This is first week, this is second week, third week, fourth week. Approximately 3 months data is collected. 3 months data is collected. Now this is available. Now I am trying to understand that person, that particular individual X, his body is behaving with respect to the various levels of calorie consumption. Let me do some analysis, like our regression analysis. Now regression analysis gives me this equation. Look at the p-value. P-value is how much? Less than 0.05 or more than 0.05?
Less than.
Less than 0.05. That means there is significant relationship. Whatever conclusion you are making, this is going to be significant conclusion. Please use your data. Please take decision based on your experimentation. Only when p-value is less than 0.05. In all other situation, you should not draw any conclusion. You should not make any changes in the process based on the experiment conducted. When will we make changes in the process? When will we consider interpreting the statistical analysis? Only when p-value is less than 0.05. And now we know the meaning of each and everything. Now regression model comes with a summary. There is S value. S means standard deviation. S means standard deviation. Or standard deviation in your Y variable. R square. R square is nothing but squared value of R. For one variable, what is R? Pearson correlation coefficient. R is Pearson correlation coefficient. For this particular set of data, if you calculate R, it will come to be 0.97. It will come to be 0.97. 0.97 means very strong positive correlation. And once R is 0.97, R square is 0.97 multiplied by 0.97. You can right now try. 0.97 multiplied by 0.97 is 94.94. Which means the weight gain is strongly influenced by the calories consumed by that individual. All of you, do you understand? Weight gain is strongly influenced by the calories consumed by the individual. To the extent of 94%. That means 94% of the weight gain is mainly due to the increase in the calories. If the person wants to reduce the weight, he should consider decreasing the calories. Nothing else. Because the relationship is so strong to the extent of R square becoming 94%. R square is known as coefficient of determination. R square is known as coefficient of determination. Let us say you want to take an important decision. You want to take an important decision in your life. Tell me whose advice you will take. Will you take your parents' advice? Or will you take your children's advice? Or will you take your wife's advice? Tell me.
Childhood parents' advice, after marriage wife's advice.
Okay. So you are now after marriage, right? So you are now depending on your wife for every decision. Whether to change the job, whether to change the city, whether to change the school for the children. Everything, the decision is influenced by your wife. If I have to make you take a correct decision in favor of me, I will directly talk to your wife and my job is done. Same way, I want to impact the Y variable here. The R square is telling me, just make one phone call to the X variable. That's all, your job is done. Because it is heavily influenced. To the extent of how much? 94%. All of you understand how to use the R square? Now there are two more R square. Adjusted R square and predicted R square. See, your R square has become 94% simply because you added the predictor variable in your regression equation. What is the predictor variable? Calorie consumption. What could be other predictor variable? Your stress level. Am I right? The number of hours you sleep.
Yes.
Number of steps you walk. There are many other factors that can also equally influence. But in spite of having so many factors, the equation is telling you that just one single factor is the major influencer. You have children, you have parents, you have a mentor, but still you are listening to your wife. That is happening here. That is confirmed by adjusted R square. Adjusted R square is telling you, you are not listening to your wife, you are not listening to your parents, you are listening only. That is the reason why adjusted R square is very close to R square. Can you see? The difference is very small. When the difference is very small, you can get your result just by optimizing the predictor variable you considered in the regression. That's all. You don't have to worry about the left out factors, because the left out factors do not have much influence. That is confirmed. How do I say? Because the adjusted R square is very close to R square. All of you understand how to use this? Can you please confirm?
Yes, sir.
Yes, sir.
Very good. Now there is one more, predicted R square. When to use this? Go to your data. What is the lowest calorie consumption value here? What is the lowest calorie? How much it is? 1,500. Okay. What is the highest?
3,900.
3,900. Suppose if I consume 4,000 calories, what will happen to my weight gain?
1.1 kg.
Suppose if I consume 4,000 calories, do you have a data available for weight gain for the 4,000 calories? Not available. Do you want to do the experiment for one more week, or do you want to use this equation? If you want to use the equation, the predicted R square should also be close to R square. Are you able to see predicted R square close to R square? Only 2%, isn't it? The minimum requirement is 80% in all the 3 R square. Then you can use the equation for all these purpose. Suppose if R square is okay, but predicted R square is not okay, then you should not use this equation for prediction purpose. Don't use it. You should not use it for prediction purpose. All of you understand what I'm saying? Right.
Yes.
Anyway, we will be seeing multiple case studies, then you come to know. And again, there are some more, factors involved, which you will be able to, understand gradually as we progress. The p-value, you all know the meaning, and VIF, variance inflation factor. The variance inflation factor will talk about the relationship within X variable. Relationship within X variable. How many X variable is there? Only one X variable is there. So you don't have to look at VIF right now, right? Because there is only one X variable, so you don't have to look at. So now moving on to another case. Now this case is a casting industry. In a casting industry, they make aluminum casting. What do they make? Aluminum casting. Porosity is a big problem in the company. Castings are getting rejected due to porosity. There are some holes inside, unfillings inside. As a result, the castings are getting rejected. Each single casting might cost several thousand rupees. Even 2%, 3% rejections due to the porosity, company can lose several lakhs every single shift. Possible or not? Possible. So the company wanted to understand why there is a porosity happening. And the brainstorming happened and all the analysis happened, basic analysis was done. And people have come to a conclusion, hey, the hydrogen content in the molten metal. The hydrogen content in the molten metal is making the castings to become porosity. So hydrogen content must be optimized. So that was the clue. Now they wanted to do a hypothesis testing. Now hydrogen content is varied. You see here, lower value to higher value. Hydrogen content is varied and porosity also is measured and it is documented. Now the regression analysis is done. You can see the regression equation. A simple linear regression only. Porosity y equal to a constant term plus slope and this thing. Now look at the p-value. What is this p-value is telling? Less than 0.05 or more than 0.05?
Less than 0.05.
That means your suspect is correct. That means the brainstorming team, whatever the experts have suggested, that is correct. Hydrogen content is actually influencing the porosity. That is confirmed. And now the value, look at the value, right? R square value. How much is the R square value?
39.04.
That means what is the influencing capacity? In the previous case, the influencing is 94%. But now
39%.
only 39%. That means what? You are not only listening to your wife, you are also listening to your parents. You are also listening to your children. Do you understand? Your porosity not only depends on hydrogen content, but also depends on X2, X3, and so on, which are missing in your regression equation. Why they are missing? The brainstorming was not conducted in a proper manner. In the cause and effect analysis, the important factor, the critical factor, some of the critical factors are missed out for hypothesis testing. That is why, your regression equation is strong enough. Your regression equation is not strong enough. That is reflecting in the R square. All of you, can you understand how the R square is helping us? That is why I always say the DMAC methodology is extremely powerful. Even if you do a mistake, that will give you an alarm. It is like a poke-okay, inbuilt poke-okay. If you are not doing a project correctly, in the analyze space itself, you are coming to know. The 9th step in the DMAC is verifying the sufficiency of the factors. Now you have considered only one factor. Tell me, with the R square of 39%, are your critical factors sufficient?
No, no.
You need to add. I do not know. What is that factor?
So we need to conduct a brainstorm once again.
Yeah, go back, call all the team and figure out what was missed out in the previous brainstorming and pick up few more doubtful factors, conduct the hypothesis testing and include them in the regression. At least R square should become 80%. Since the R square itself is weak, you don't have to look at the other factors here, right? All of you understand how this R square is helping?
Sir.
All right. Now we are going to talk about, understand about two more terminology, confidence interval and prediction interval. What is confidence interval? After framing the regression model, if my predicted R square is good, hereafter, instead of conducting the experiment, I will start using the equation. Like next week, Wednesday, afternoon 3 o'clock, what will be the location of the satellite? ISRO want to know. Do you think ISRO will be able to tell what will be the location of the satellite next week, Wednesday, 3 p.m.? Tell me, is it possible or not?
Yes, sir.
Possible. Why? Because they have a beautiful regression equation showing the motion of the satellite, with the R square, with the predicted R square close to 100%. That is how they are able to see the satellite as a small piece of ball in the monitor, keep on moving around the earth. And they can correctly guess what will be the exact location next week. And that will definitely happen. Same manner, if your regression is also stronger, you can also predict what kind of outcome will happen when I set the X to certain value. When I change the settings of X, what will happen to my Y? My prediction equation will tell. I will use the regression equation as a prediction model for prediction purpose whenever my predicted R square is more than 80%. Now see here, this is a case of the weight of babies in the age group of 0 to 12 months. What is Y variable here? Weight of the babies, kids in the age group of 0 to 12 months. What is X? The height of the babies in centimeter. If the height is more, what will happen to the weight?
Weight will increase.
Weight will increase, right? So once you have a study about babies born in, born in India, in a particular city, if you have the proper data, with the data, you can judge even the weight of the baby once the height is known. So a hospital has maintained, the relationship, data about the height of the babies and the weight of the babies. Right. So now when the height is 75 centimeter, what could be the weight of the baby? And now it is predicted. It is predicted. And now see here, now always when you predict, the predicted value is 8.74. And now you have to tell an upper limit. Upper limit is 8.92. Lower limit is 8.55. The upper limit is called upper confidence limit. Lower limit is called lower confidence limit. How these limits are calculated? Fitted value plus or minus a statistics called T. You all know T test, right? A statistics called T distribution multiplied by standard error of the fit. Multiplied by standard error. Standard error is standard deviation divided by square root of sample size, right? So using this, the upper limit is calculated, lower limit is calculated, and now these are called confidence limit. Confidence limits are helpful to judge where the average value of your output will fall. Once you have the upper limit and lower limit, you can confidently say the average value of the output will fall inside the limit. All of you, do you know the average meaning of average? If you do 2-3 experiment, you will get 3 y values. Am I right? Do 3 experiment, 3 y values. Now calculate the average. Average of the 3 output. The average will certainly fall between upper confidence limit and lower confidence limit. So confidence limit means the limit within which the average of an experimental outcome will certainly fall. That is the idea. Now there is one more limit called prediction limit or prediction interval. And now see here, fitted value is 8.74. For the same fitted value, look at the upper prediction limit and lower prediction limit. 8.3 and 9.1. In the previous case, how much they were? 8.5 and 8.9. Now, which is wider? Confidence interval is wider or prediction interval is wider? Prediction interval. So the prediction limits are generally used to capture an experimental output. But here the number of permitted number of experiment is only 1. If you do only 1 experiment, and how many output you will have? Only 1 output. You don't have a chance to take average now. Under such situation, you must use prediction interval. If the company is allowing you to do multiple experiment, you can better use confidence interval. But what should you expect? You should expect the average of your experimental output to fall inside confidence interval. It is something like, if let us say I'm conducting an exam. And I have the regression equation of your test performance because last 1 year data is available. I have framed the regression equation. Now you are going to write an exam next week. How many exams you are writing? Only 1 exam. Now I am trying to predict your mark. Now I will use prediction interval because only 1 exam you are going to write. All of you understand what I am telling? Suppose next week, if you are going to write 3 exams, then the average mark of your 3 exams will fall inside confidence interval. All of you, do you understand the difference between confidence interval and prediction interval?
Yes, sir.
How it comes and how the equation is derived, you can take some time to digest, but use the prediction interval if you have only 1 experimental output for prediction purpose. If you can make multiple experimental outputs, then you can use confidence interval. Yes. Now comes, so the prediction interval is always wider. And this is again for the calories case, for calorie consumption and weight gain, the prediction interval is wider. However, the confidence interval will be narrower, right? So just some visualization I have brought here. And now let us collect the last one more case study. See here, the height of the babies in centimeter is available. The weight of the baby in kilogram is available. Height of the baby and weight of the babies in kilograms is available. And where this kind of data will be available? In a hospital. A hospital is taking care of kids up to the age of 1. Up to the age of 1. So they have this data. And now they also have a regression equation. Now when the height of the baby is 75 centimeter, what will be the baby's weight? Do you understand how the hospital is trying to use the regression equation? Now the regression equation is developed. Look at the fitted value. Fitted value is how much? 8.74 kg. And what the hospital is telling now, if the baby is having a height of 75 centimeter, it will have a weight of 8.74 kg. But there is an interval because I cannot give perfect value, isn't it? So there is an interval. Look at the interval, 8.5 to 8.9. What is this 8.5 to 8.9? Confidence interval. And here one more interval, 8.3 to 9.11. Can you see this interval little wider?
Yes, sir.
So this is prediction interval. This is confidence interval. I have told you how to use prediction interval and how to use confidence interval. If there is only 1 experiment you are going to do, which interval you will use? Prediction interval. If you can afford to do multiple experiment, then you can expect your average of the experimental output to lie inside confidence interval. Now, for the same data, the regression analysis is done. The regression analysis is done, and this is actually the ANOVA table, and you can see the p-value is very small for the factor height, because the weight of the baby is mainly depending on the height of the baby. The weight is mainly influenced by the height. And R square, look at the R square, 99. Adjusted R square, 99. Predicted R square, 98. Can you use this regression model for prediction purpose?
Yes, sir.
Definitely. That means the moment the baby is formed in the mother's, portion, then, if you, through the scanning, if you can measure the height of the baby, will you be able to judge on the weight of the baby inside?
Yes, sir.
Possible. Because you have a beautiful regression model, through the scanning image, if you could find out the height of the baby in centimeter, how much is the weight in the first month, second month, whether the baby, is staying healthier or not, you can make some meaningful conclusions. All of you, do you understand why they take scanning and then why they do all this interpretation? And now let us take few scenario. For the same situation, model is created, regression equation is available. Height of the baby is considered 40 centimeter. Now what will be the weight of the baby? See here, when the height of the baby is 40 centimeter, what is the weight of the baby? How much is the weight?
1.219.
That means the baby is still either underweight or it is still inside the mother. Isn't it?
Yes.
So according to the duration of the pregnancy, you can judge whether it is a healthier weight or not, and doctor can change the treatment accordingly. Now another scenario, and for the same regression equation is giving you confidence interval, giving you prediction interval. Do you know why now we have confidence interval and prediction interval? If you have done only one scanning, which interval you should look at? You have done only one scanning. Now,
Prediction.
Prediction.
Though you say the baby weight is 1.2, God only knows whether the baby's weight is exactly 1.2 or not. Am I correct?
Yeah.
So what if at all the situation is worst? Still the baby weight can be considered 0.78 kg. If everything goes well, you can consider the baby's weight as 1.65. Including the uncertainty, the range is predicted. Including the maximum uncertainty, the range is predicted, which is prediction interval. If you see, when the interval is wider, then the doctor will be, will have a more confusion. Am I right? Yes or no?
Yes.
So in order to minimize the confusion, doctors will generally go for probably 2-3 images they will take in the scanning. Am I right? So
Yes.
you will have 2-3 experimental outputs. Now the average of the experimental output will lie between these two. Now which one doctor will look at? The confidence interval or the prediction interval? Which is a better method?
Confidence.
That's how. Because the decision you are taking is very critical to the child and the mother. You have to be careful. Take 3 images and expect the average to be here. And now you are able to judge better. When the interval is wider, your judging, cannot be, perfect. And now the perfection can be much more better when you use confidence interval. But to work with the confidence interval, you need to increase the number of experiments, right? On the other side, you will be spending. Similarly, the another scenario, when the height is 60, what is the weight of the baby? When the height is 75, what is the weight of baby? Confidence interval available, prediction interval available, whichever you want to use, you please use. Similar situation, you may also come across. You may replace the position of the medical doctor in your company, isn't it? A chemical process is happening. So what is going to happen to your Y variable when you change the X variable, to a particular value? And you can do the experiment and judge, or if you have a strong regression model, without even doing experiment, you can judge what is going to happen. This is called simulation. All of you understand? This is called a simulation. You are just using an equation to predict what is going to happen for different settings of X values. So all of you understand how the regression analysis is helping us?
Yes, sir.
Yes. Yes.
So R square for any regression model will always increase when a new term is added. That is, depending on the number of X factor, R square will improve. However, sometimes R square may improve wrongly. That is why we have adjusted R square. So always a better idea is to look at the adjusted R square, not the R square. Like how we look at CP how we look at CPK instead of CP. Same way, look at adjusted R square, not the R square. Similarly, for prediction purpose, you must look at predicted R square. All the three at a time, if they are more than 80%, your model fitting is perfect, right? A 95% confidence interval indicate your values. Indicate that the average of your experimental output will fall inside the confidence limit. Similarly, the prediction interval means the single observation. Single observation is expected to fall inside the prediction interval. Prediction interval will be always wider than the confidence interval. So this is what I wanted to share with all of you about correlation and regression analysis. So I think all that required is a set of data. Am I correct? If you have set of X values, set of Y values, then regression equation can be framed. Any questions to me? Any questions to me? Anybody would like to ask?
Clear.
Very
Clear,
good.
sir. Clear.
So already how to use Minitab, I think we have discussed. Probably the people in the classroom session, you can ask Vinod Shankaran sir to help you with how to use Minitab for regression analysis. Similarly here, whenever if you have any doubt on using the Minitab for this purpose, I can definitely show. So I think we can now continue with our own agenda. Participants in the MSME Gindi office, thanks for your participation. How was the experience? Is it a good experience, or do you find any challenges listening to me in an online mode while you are present physically?
Nothing, sir.
It was easy, right? It was comfortable, fully comfortable, right? Except that.
Same only, same experience. Both are same. Online as well as classrooms also same.
All right, perfect. So happy to.
We also adapted.
Very good, very good. Thank you. Provided the audio, video, and the qualities were good, and except that one disconnectivity. So tomorrow there will be, I will be there, and Shankar will be there. So we will do it that way tomorrow. All right. So thank you so much, Vinod Shankar sir. Thanks for the arrangements.
Thank you.
For the connection.
All
the best. We'll continue here, and you can continue there. Bye-bye. Done. So participants, you have any questions to me? Was it good? The discussion about correlation, regression?
Yes,
sir. It was
Make
good.
use of all these tools, provided the result you are trying to impact is very critical. Use all these tools. Know in advance what is going to happen before taking a decision, before making a change, and then make the proper changes. So now the time is for Dr. RK, and he can actually going to help you with his several Excel templates he has given. Hope all of you are downloading, isn't it? Please download. All these templates are precious templates. And if you really wanted to buy, then you may have to pay another 20,000-30,000 rupees to just get all these templates. But we are giving you free. And we are also now going to explain how you can actually use those templates, right? For some half an hour or 40 minutes, he will just demonstrate certain templates, particularly how you can make use of the templates for hypothesis testing, because hypothesis testing is little, tougher module. So over to Dr. RK so that he can explain the template.
Thank you very much. It's all